Welcome to today's episode, where we dive into predictive maintenance and asset risk management, focusing on the time in-state methodology developed by IME Solutions. Our audience today is well versed in maintenance and reliability engineering, and will explore how time in-state helps optimize production processes, reduce downtime, and boost the overall reliability of equipment within processing plants. Let's start by setting the stage. Time in-state is a system and a comprehensive methodology designed to enhance asset management and process control. At its core, it addresses two primary functions. First, it identifies operational risks and root causes of process inefficiencies by analyzing historical data. Second, it serves as a predictive maintenance tool through real-time interpretation of control system readings. Let's explore these two functions in detail. Let us discuss time in-state as a diagnostic tool. The diagnostic side of time in-state is all about using historical data to understand and manage risks tied to the operational state of assets. When applied as a diagnostic tool, it maps the as-is state of the plant and compares it with an ideal or benchmark state. This mapping reveals deviations highlighting where performance losses occur, how they impact equipment life, and which areas present significant risks to stable operations. Through this historical analysis, the methodology can pinpoint the sources of deviations and assess their impact on production quality, energy usage, and throughput. For example, suppose a piece of equipment like a mill motor or gearbox consistently strays from its ideal operating state. This variation is logged and analyzed to identify whether it's due to process instability, external disturbances, or aging equipment. Essentially, the time in-state diagnostics phase is where we gain insight into underlying issues. This allows the plant team to design targeted solutions and set optimal operating conditions for each piece of equipment. This phase provides a solid foundation, enabling the transition to real-time monitoring, where the real-time version of time in-state comes into play. So what is time in-state real-time monitoring? Now, let's move to real-time monitoring, which is arguably where time in-state shines in delivering predictive maintenance capabilities. Here, the models established during diagnostics are applied to real-time data streams. Imagine it like a vigilant monitor that reads sensor data, such as pressure, temperature, or flow rate, interpreting each reading against predefined optimal conditions. By constantly measuring performance metrics, time in-state can detect when conditions are moving away from ideal thresholds and can alert maintenance teams well before any significant failures occur. For example, in the case of a gearbox, time in-state might integrate readings from oil pressure, accelerometers, and temperature sensors. This integrated model can catch deviations, sometimes as much as 24 hours or even 6 weeks in advance. Such early detection allows teams to address issues preemptively, avoiding unscheduled downtime and extending equipment lifespan. One illustrative case involved a mill motor where, by monitoring brush gear performance, time in-state flagged issues before they escalated, ultimately saving over $1 million annually. Another case involved a lubrication system where an anomaly indicated that an incorrect oil grade was accidentally used, prompting immediate corrective action. In both scenarios, time in-state acts as a safety net, ensuring operational continuity and asset reliability. Let us briefly talk about integrating maintenance and control systems. Time in-state isn't limited to diagnosing equipment issues. It also optimizes control systems. A common pain point in maintenance is the overwhelming amount of control instrumentation, making it challenging to prioritize and effectively monitor each element. With time in-state, control element performance can be systematically tracked, making it easier to identify and prioritize the maintenance of critical instruments. Unlike traditional methods that may focus on individual components, time in-state analyzes the interrelationships of various parameters within a unit. This approach helps maintain the process within defined benchmarks, reducing stress on equipment and minimizing deviations from the target performance metrics. The next question is, how do we bridge the gap between maintenance and production teams? Let us start by explaining how this methodology and technology address predictive maintenance. Time in-state doesn't just tell you when maintenance is required, it provides a broader picture by examining why a process might be deviating and how that impacts the system as a whole. It effectively bridges the gap between predictive maintenance and process optimization, providing actionable insights for both maintenance and operational teams. This dual focus means that maintenance and operational decisions aren't made in isolation. For instance, if time in state detects a consistent deviation in one process area, it highlights whether it's an asset-specific issue or a process control issue. Each alert includes context, ensuring that corrective actions target the root cause rather than just treating symptoms. In conclusion, how does time in state contribute to asset management? In wrapping up, time in state represents a significant leap forward for the processing industry. It aligns asset management and process performance through analysis and real-time insights, creating a feedback loop that drives continual improvement. Identifying and addressing the causes of deviations helps plants maintain stability, extend equipment life, and ultimately boost overall efficiency. Whether used for historical diagnostics or real-time monitoring, time in state equips plant teams with the tools to stay one step ahead of risks, reducing maintenance costs and increasing reliability. It's not just about predicting failures, it's about creating a more resilient, efficient, and data-driven production environment. Thank you for tuning in to this episode. If you want to learn more about time in state or implement it in your plant, visit IME Solutions website. Stay tuned for our next episode, where we'll explore more innovations shaping the future of predictive maintenance. Until next time, keep innovating, stay efficient, and aim for excellence.